So hello guys, welcome back to my channel. So right now I'm studying chapter number 2, physics, and practicing the dimensions part. So let's go. And in this video, I'm also going to tell you or explain you what the topics I'm studying in chapter number 2, units and measurement, which are very easy. First of all, whatever I have studied yet, I'm on dimensions topic, which is the second one, and I want to explain you both of them because it's very interesting and it will help you in your studies also. So the very first thing is physical quantity, which is also represented by PQ, which is actually the quantities which can be measured by the instrument and which describes the laws of physical world. The formula of this is n into u. This is a very simple formula and I hope you guys know about it. N is basically the numerical value and u is the unit. This is the formula that we have also been discussed in the ninth class. Along with that, I want to tell you guys that physical quantities are of three types. Physical quantities are of three types. Let me just tell you. The number one is fundamental, another one is derived, and the last one is supplementary. So these three are very easy types of physical quantities. First of all, fundamental physical quantity is which don't depend on any other physical quantities, which is independent of any other one. And the next derived is actually derived from fundamental quantities, for example area, for example velocity, volume, everything. After that, supplementary physical quantities include solid angle and plane angle. Solid angle, which is which does not have any dimension, and the angle is represented by theta, so it's simple. Along with that, I want to tell you guys the thing is fundamental quantity is the most important physical quantity, which are of seven types. And one physical quantities, number one is length, second is mass, then we have time, after time we have temperature, after temperature the next fifth one is temperature, electric current, then the sixth one is luminous intensity, and the last one is actually, wait a second, the last one is seventh, which is amount of substance, mole. All right, so guys, let's now move on to dimensions. So dimensions are, first of all, the definition says that they are the powers to which the fundamental units are raised in order to express the derived unit of a quantity. So basically they are actually the powers to which the fundamental units are raised into the derived unit of a quantity. Let me explain you with an example. For example, we take an example of area. Area is equals to meter square. Area is equals to meter square. So these fundamental units are been given a derived unit. For example, length is given a derived unit, like for example length have a symbol of meter, right? But it have been given a derived symbol, which is L. Similarly, mass have also been given a derived one, which is M. Similarly, out the length, the derived formula, the derived symbol that it is used as L. Mass we will represent it with M. Time with T. So all of these things are used to find out the dimensions actually. So if we say area in length, we will write it L2, and if we will say what will be the dimension of area in length, then the answer would be that it is 2, because they are the powers of what? They are the powers in to which the fundamental units are been raised to express the derived unit. So thus we can say that the answer would be 2 here. For example, if we take another example of volume, if I explain you with another example, which is volume, the volume is equals to meter cube, then it would be represented with L cube. Also, I forgot to tell you that these things are explained in the terms of MLT. I mean mass, length, time. Even though if it is not including, the formula is not including, actually here also, and in the area side also, it is not including any mass or any time. Even if it is not including mass or time, you have to represent it in the mass and time MLT form, because it's basically more appropriate to just find it in this form, to just write it in this form. So lastly, in the area, if we will talk about the area, then area would be written as m0, because there is no mass, there is length which is 2, and there is time which is 0, because there is no time over there also. Or here there is L3, but as we can see that there is no time, no mass. So what we will write it, we will write it as m0, L3 and T0. So these are simply dimensions. There are a lot of other examples. If we will take another example, so let us take another example of density. So we know that density is equals to mass upon volume. Mass upon volume. So mass is represented with kilogram. Kilogram upon meter cube. So kilogram upon meter cube. So we will represent kilogram with mass, and mass is represented as m, and meter cube L cube. So here the answer would be m1 L minus 3 and T is equals to 0, as there is no T. There are numerous of questions of dimensions which you can perform, and I have performed more than 30 questions. So just to make myself perfect in this area, and I want to tell you guys that you can too perform a lot of questions as much you want. And if you want more questions related to this topic, you can let me know in the comments below, and I'll just tell you those questions or share them in my next video. Along with that, I just wanna end this video by telling you just two examples more of force and work done related to which are example of dimension of physical quantity. So let's go. Force is equals to mass into acceleration. So it will be like mass is represented with m, and acceleration is changes velocity upon change in uh, like change in time. So it will be meter upon second, which is velocity, into second, which is time. Then it would be like meter would be length and time ka square. After that, meter, sorry, mass 1 L1 and T minus 2 as it is in denominator. This would be the formula of mass and the answer. Next thing is a work done. So the work done will be, work done is equals to force into displacement. So force will be mlt minus 2 as we have been taken out in the above. Also, this is a very important formula, so you need not to forget this. You have to learn this because it's used in many other formulas, making like to make other formulas too. Like we are making the formula of work done, and it is used over here also. And then this will result to the formula of work done, which is m1 t2 L2 and T minus 2.